let's take a relook at what the component representation was. So basically, we saw that if we have a two-dimensional coordinate frame, the standard x and y axis, which are perpendicular to each other, and within that we have some kind of a vector which is drawn from the origin, suppose. Just a moment, people seem to be having a software hand. Right, so we were going to take a relook at the concept of component representation of a vector. And to that end, what we saw is that with respect to a standard xy coordinate frame, if we have a vector such that its magnitude is, suppose E, and it is inclined at an angle theta with respect to the x-axis, then in component representation we say that this vector is represented by the equation vector E is equal to Ex I cap plus Ey j cap, where we understand that I cap and j cap are what we call standard unit vectors. So I cap and j cap are the unit vectors along positive x-axis and the unit vector along the positive y-axis. And Ex and Ey, they are called the component of the vector A along x-axis, or simply the x component, and similarly Ay is called the component of the vector A along the y-axis. So this second equation that we written over here, this is what we call the component representation of the vector, or the vector is written in component form, whereas earlier in the diagram you can see the vector is shown in the geometrical form. That is, you know the magnitude of the vector, the length of the arrow, and the angle it is making with the x-axis. So you know the geometrical properties. Now the relationship between these two we saw was that the quantity Ax is defined as E cos theta and Ey is defined as E sin theta. Or conversely, you can say that the magnitude of the vector E is nothing but square root of the x component square plus the y component square, and theta is such that tan theta is equal to Ey by Ax. All this is part of what we learned last time, so I'm not going to again and again repeat the same thing. You have my whiteboard notes from last lecture also that has the same things expressed in a lot of detail. So we will start with, now the main thing here is that understand here that cos theta and sin theta are calculated according to the principles of trigonometry in 4 quadrants. Okay. That is what in maths we also call the ESTC rule. Okay. Things like in second quadrant, we have sin theta is positive of sine 180 degrees minus theta, but cos theta is negative of cos 180 degrees minus theta. Similarly, in third quadrant, we have the formula sin theta is negative of sine theta minus 180 degrees, and cos theta is negative of cos theta minus 180 degrees. So just as a quick example, you want to calculate cos of, let us say, 240 degrees. So that we recognize as quadrant 3. So we use this formula here. And according to this formula, cos 240 becomes minus of cos theta, that is 240, minus 180. So that becomes minus, correct. It becomes minus half. Minus cos 60, so that becomes minus half. So these are the principles that we use, okay, when we are substituting sin theta and cos theta for a given vector like this. So if the vector is in the second quadrant, theta will be obtuse. If the vector is in the third quadrant, theta will be between 180 and 270. And accordingly, when we are calculating the components by these two formulae, E cos theta and E sin theta, we will have to take into account these particular conventions or these particular formulae for each of the quadrants. Okay, similarly, fourth quadrant, we write sin theta as minus of sin 360 minus theta, and we write cos as positive of cos 360 minus theta. These are the standard conventions that we keep in mind. Okay, so let's start with a couple of questions which are again just the basic application of components to convert a given vector into component form. So I'm going to give you a few vectors which are randomly drawn like this in the xy plane, and we have to express them in component form. So let's start with, suppose a vector E is given like this. This. Then we have a vector B which is, let us say, like this. And suppose we have a vector C which is like this. Let us say this vector C is also magnitude 10, but this angle is 37 degrees. And finally, we have one more vector. Let us say vector D or something. This is like this. This one is of magnitude 16, and this angle here is 60 degrees. Draw parallel to the x-axis. Now, this is what we have to do. We have to express all these vectors in component form. Sometimes we also just call that I cap J cap notation, or component form. So just try this out, people. You can send me the answers on the text message. Okay, so let me mute
such
it.
statements happen.
Yeah, Ritika, your answer is correct. Somarup, your answer is not correct. Yeah, uh, no, you people are not getting these correct. That means you haven't understood trigonometry in 4 quadrants at all. So let me explain each of the parts. Just stop whatever you're doing. It's not correct. So each of those vectors, you have to understand them in detail, okay, from the diagram that is given above. So if you look at the vector A, to understand it in component form, what we have to do is you have to place a vector A at the origin, and from that you will understand how much angle it is making with the x-axis. So if you pick up this vector A and redraw it from the origin over here, you will see that the vector A is like this. This angle is 90 degrees. So for vector A, you can see that the magnitude of the vector is 10 and the angle it is making with the x-axis is 90 degrees. So obviously its x component is how much? It is 0. You can see that in the diagram also, and you can see it according to the formula also, that x component is a cos theta and y component is a sin theta. So I expect you people to get these basic things correct. After one lecture we have already done on this, this becomes 10. So the vector A in component form simply becomes Ax I cap, which is 0, plus Ay j cap, which is 10 j cap. That's it. That's the answer for the first part. Now, the second thing, if you look at the vector B, the vector B is lying in the second quadrant, and most of you are sending me answers where both the components are positive. So how is that logically possible? I've explained so many times that the vector B, I mean, you have to apply trigonometry in 4 quadrants. So for the vector B, you have to understand that the vector is making an angle with the x-axis, which is not 30 degrees. It's making an angle with the x-axis, which is an obtuse angle. The vector B was drawn like this. So pay attention to what you're doing. You can't tell me, sir, what was the formula today? The formula was told in the last week. So this total angle, this angle theta for it will become how much? It will become 90 plus 30. This is the angle. Go back to the diagram and see what I had drawn. The angle with the y-axis was 30 degrees. So with the positive x-axis, the angle is how much? It is 90 plus 30 or 120 degrees. So the magnitude of the vector is 12. And the angle with the x-axis is 120 degrees. So the x component, which is b cos theta, will become 12 cos 120 degrees. Now we just discussed how to calculate cos 120 degrees. It is minus of cos 60 degrees. So it is minus half. So it becomes minus 6. So the x component of b is minus 6. Similarly, the y component is 12 sine 120. Now please do these steps correctly yourself and show that by should come out to be 6 root 3. I'm not going to do all the steps over here. You have to do it out yourself and work it out correctly. So the vector b should be expressed as minus 6 I cap plus 6 root 3 j cap. which you can see makes sense with respect to the diagram also. Because if you now compare this working with the diagram for vector B, when you drop the perpendicular from vector B on the x and y axis, you can see that the x component is on the negative side. It's -6. The y component is on the positive side, and its value is 12, rather 6 root 3. That is why the vector B is ultimately becoming like this. Okay. So please use this example properly and understand how vectors C and D will also be expressed over there in that diagram. Most of you have again given C also with positive x component and positive y component, whereas if you go back to the diagram, you can see it is not that way. Yes, Ritika, it is correct. Answer for D is correct. Ritika, have you done the C part? Okay. Try this part C also, Ritika, but your answer for D is correct. Yojit, you have got the wrong values of sine theta and cos theta for C part. Okay. So I'm just going back to the diagram here. I'm giving the answers in this. I will show the working also, but try to understand why these answers are correct. So the vector C will have an x component which is -8 and a y component which is +6. Okay. So far only one person has got this correct. Most of you got the signs mixed up. And the vector D accordingly will have an x component which is -8 and a y component which is -8 root 3. So this also only one person has got correct so far. Okay, so for each of these parts, what you have to do is you have to redraw the vector from the origin so that you know the angle at which it is lying. So I'm just demonstrating part C and part D for you again. So for C, I've shown you a vector like this. Vector was like this, where its magnitude was 10 and this angle was 37. Now to understand what kind of angle it is making with respect to the x-axis, you have to pick up this vector and place it over here. So that's what you have to do. You have to replace the vector, you have to reposition it with respect to your origin so that you can understand what angle it is making with the x-axis. So if you reposition it with the origin, you will see it's the same vector which you have now placed over here. So its magnitude is 10 and this angle is 37 degrees. So the angle it is making with the positive x-axis, that theta, so magnitude of C is 10, but the angle is making with the positive x-axis is in fact 180 minus 37 or 143 degrees. So the x component will become 10 cos 143. Now again that will become minus 10 cos 37 degrees, okay, and that will become minus 8, because you know that cos 37 is 4 by 5 and sin 37. I told you to memorize these values also separately. I given you that table of values last time. Okay. And similarly, Cy will become 10 sin 143 degrees. So doing that, you will get its value as plus 6. So the vector C now in component form will become the x component, which is minus 8, plus the y component, which is plus 6. This should become our answer. Yes, I mean it's pretty obvious how you got that angle. You just extend, see these are parallel lines. So this angle is equal to this angle and this line is parallel to this. Okay, so hope this is completely clear now. Yeah, Rahul, to answer your question, I did not say I placed it from one quadrant to another. I said that the vector has to be drawn from the origin. Okay, so any vector arrow, it has a starting point and it has an ending point. The arrow is drawn between a starting point and an ending point. Now, to understand what angle it is making with the x-axis, you have to place the starting point of the vector at the origin. Otherwise, how will you gauge what angle it is making with the x-axis? Otherwise, what we'll have to do here is you have to redraw your x and y axis. If it is over here, you can see your x and y axis are like this. So that is the same thing here as replacing it over here. Okay. So that is why to gauge the angle of any vector, you have to reposition the vector at the origin. It's not a question of whether it's first quadrant, second quadrant, third or fourth. Whatever the given vector, a vector is given at any point anywhere like this, you have to reposition it over here so that you can find out what angle it is making with respect to the x-axis. Okay, now likewise, please work out the last part, the D part. Try to get it correct now. I've already given you the answer, but try to understand why you're getting the answer as that. If this is the vector drawn. So apply this method over here and show that the vector D will be this. Correct, Somarup, that's correct. Yes. No, then is the components of opposite vectors won't be equal. They will be negative of each other. If one vector is x1 I cap plus y1 j cap, the other will be minus x1 I cap and minus y1 j cap. Yes, D will be in the third quadrant, beta. So both will be negative. Both components will be negative. Yes, Yojut and Hitanshu, to answer your doubt, yes, because D, when you reposition it from the origin, you can see it's lying in the third quadrant. So both the x and y components are negative. If you just visualize the vector D here, this vector, it's like this. So it has an x component also which is pointing in the negative direction. It has a y component also which is pointing in the negative direction. So that's how the vector D is. It is having some negative x component. Dx is also negative and dy is also negative. But exactly how much it is, for that you need to figure out the angle. So for that, to help you out, this 60 degrees is given. Okay, people, so hope this concept is clear so far. So let me complete the problem D for you. So the vector D will lie something like this. What I had shown over here, we'll have to reposition it and place it here. Now this angle was 60. So you can see that this angle is 60. So here this angle is 60. So if this angle is 60, what about the angle it is making with the x-axis, the positive x-axis? It's this angle. So this theta for the vector D, theta is actually becoming 180 plus 60 or 240 degrees. Okay. So cos theta will become minus cos 60. So that's minus half. And sin theta will become minus sin 60. So that is minus root 3 by 2. Okay. And the magnitude of D was 16. So your x component you can see will become 16 into minus half. So that is minus 8. And your y component will become 16 into minus root 3 by 2. So that is minus 8 root 3. So your vector D now expressed in component form become minus 8 I cap. This is the vector. Okay, people, so hope this is clear. Good. Yeah, the question had the same information about B. B was drawn like this. Okay. So one by one we have solved each of the parts. Vector E became like this. Vector B was minus 6 I cap plus 6 root 3 j cap. Vector C was also in the second quadrant, minus 8 I cap plus 6 j cap. Vector D was the one which was in the third quadrant. Okay. Now, when we start doing algebra of vectors, addition, subtraction, etc., using components, you'll understand why it is so important to get these signs correct. If I make a mistake over here that I write vector D instead as, let's say, 8 I cap minus 8 root 3 j cap or something else, then it totally is going to give me the wrong result when I'm going to do algebra with it. Because now see, it's like now if I give you this vector and from this I ask you how does the vector D look, you'll get it correct because you can see the x component is negative, it is 8 minus 8. The y component is negative, it is minus 8 root 3. So the vector D itself will be like this one. But if I got one of these wrong, then you would have pointed the vector D in some other direction. So how it would have matched the original vector that we are trying to write in component form. So that is why it is very necessary that we are able to get the the sign cos with the correct algebraic sign. Okay, when we are doing this component notation. So in fact, this process we have done, that we have written a vector, we have converted into I cap j cap notation. This is also called resolution of a vector. Okay, this process is called resolution of a vector, so in this case vector D, into its components. The question might ask you that resolve a vector. No, we can't take vector D in first quadrant beta, because the vector D's arrow is pointing in this direction. वही मैं कह रहा हूँ. अगर मैं vector D को 8 I cap plus 8 root 3 j cap लिखूंगा, तो what direction it will point in? It will point like this, no? A vector in the first quadrant is like this, whereas a vector in the fourth quadrant, third quadrant is pointing like this. Now these two are not the same vectors; they are opposite vectors. Okay, let's say I tell you I made a displacement of 8 I cap plus 8 root 3 j cap, and somebody else has made a displacement of minus 8 I cap minus 8 root 3 j cap. Would their displacements be same? No, no, because they'll be going in different directions. They'll be going in opposite directions. So that is why one has to be very clear about the direction in the case of a vector. No? That is the whole point of vectors. That direction is as important as magnitude. Okay. So I hope that point is clear. Why we cannot take a vector D like this, which is in the third quadrant. We cannot express it in the first quadrant. Okay, good. So now let us do an example which has the opposite kind of situation. The vectors are given to us in component form, and we have to find out the magnitude and the direction. So given the following vectors in component notation, component form, we have to draw the vector arrows to represent them in the xy plane, and also find the magnitude and the angle theta with respect to the positive x-axis for each of them. Okay. So now I'm showing you that, or I'm giving you the vectors. So the vector E is root 3 I cap plus j cap. The vector B is minus 20 I cap plus 15 j cap. The vector C is minus 2 I cap minus 2 j cap. And the vector D finally, let us say 12 I cap minus 16 j cap. So for each of these vectors, we have to do this whole thing. We have to do this operation. Try this out, people. Yes, very good. E is in the first quadrant, Ritika, that is correct. your first answers. Yeah, quadrants and all are fine. Now just yes, Hari Tiwari, your answer is correct. For magnitude of A, you have to also give the angle. Yes, correct. No. Hari, your answer for A is not correct for the angle. Hari, just check your answer for the angle. Okay, Yojit, your answer is correct for angle. Somarup, your answer is correct for magnitude of vector B. Yojit, your answer for which one you have said 37? No, it's not correct. Yeah, Somarup, your answer is correct for this vector B also. Ritika, your answer is correct. Hari Tiwari, your answer is correct. Pradnesh, your answer is correct. Priyank, your answer is correct. Shomorup, your answer is correct for the third one also. Ananya, your answer is correct. So I will just put up the answers for the first two. So for E, the magnitude of the vector should come out to be 2 and the angle with the x-axis should come out to be 30 degrees. Okay. For B, the magnitude of the vector should come out to be 25 and the angle should come out to be 143 degrees. Similarly, you find out for C and D also. Yes, Shomorup, your answer is correct again. Okay, so let me explain the first and let me first give you the answer of this third and fourth, so that those who have finished the first and second, you can try out these now. So the magnitude of vector C, as so far two people have got it correct, is this much, and the angle will become 225 degrees. And for vector D, the magnitude will become 20 and the angle, you can write it as minus of 53 degrees or (307 degrees). Depends on how we want to write it. Okay, so let me start with the explanation of the first two. So vector E was given as √3 I cap plus j cap. That means the x component was positive of √3 and the y component was positive of 1. So first of all, let me draw the vector in the xy plane. The moment I do that, the rest of the things will automatically become clear. So my vector E has to have a positive x component of root 3 and a positive y component of 1. So if you just understand this rectangle, it has to be the diagonal of this rectangle. This has to be the vector E, and this is the angle we are talking about. So now we use the formula that magnitude of the vector E is square root of x component square plus y component square, which will become 2 when you substitute this here. Okay. And that tan theta is equal to y component divided by x component. You can see this is the y component here. This is the x component here. So tan theta is perpendicular upon base. So it is 1 by root 3. So that means that theta is equal to 30 degrees. So this same method now we have to apply for each of the vectors. Given the vector in component form, we will first draw it and understand which quadrant it is lying in, and then we will solve using trigonometry. The tan theta is y component divided by x component. Now similarly, let's go back to our vector B, which was minus 20 I cap plus 15 j cap. So let's figure that out. So the vector B was like this. Okay. So first let's figure out how it looks in the quadrant frame. So the moment you draw it in a proper XY system, you'll realize that it lies in the second quadrant because it has an X component which is negative and a Y component which is positive. You can see that the vector B here, it has a negative X component minus 20 and a positive Y component of plus 15. So the vector itself will be like this. This is roughly where your vector B is lying. And this will be the angle theta for it. Okay. So the magnitude of the vector B, you can see, is again coming from square root of x component squared. So since it's whole square, that minus sign is not important actually. So that is 25. But what about tan theta? It is by by bx. So that is 15 upon minus 20. So it becomes minus 15 by 20. So that is minus 3 by 4. Okay. And you can see that theta is in the second quadrant. Okay. So theta is in quadrant 2. So tan theta is negative of tan 180 minus theta. Okay. So you can understand that geometrically also over here, if we label this angle as an alpha, so that is minus tan alpha over there, where alpha is equal to 180 minus theta. So now, since we already know from the components, tan theta is equal to minus 3 by 4. That means from here, minus tan alpha is minus 3 by 4, or tan alpha is 3 by 4. So that means alpha is how much? Alpha is 37 degrees. So that means now what is the proper theta? It is 180 minus alpha, or theta is 143 degrees. So this becomes our final answer. Okay? So for this particular question now, our answer becomes this, that the magnitude of the vector B is 25, and the angle it is making with the x-axis is 143 degrees. Okay, so pay close attention to how this question has been solved. Okay. And make sure you understand the thing of second quadrant over here carefully. Because the x component is negative and the y component is positive, we know the vector's angle is in the second quadrant. Okay. So just make sure you understand this carefully. And I'll take you back to question for C and D part also. Just finish noting this down first, then I'll take you back to the original question for part C and D and try and work it out. Okay, so hope this is clear to all of you. I'm taking you back to the other two parts of the question. So apply the same method like I've done for A and B. Do exactly the same thing for the other two. First, draw the vectors. Yes, Somarup, you can use the alternative, trigonometry equations of expressing second quadrant as 90 plus something and third quadrant as 270 minus something. But those are just alternative formulae, and too many formulae, it can be a little confusing. So for our vectors purpose in physics, I'm using the reference of 180 degrees for second and third quadrant and 360 degrees for fourth quadrant. Okay, there's no difference at all. So to answer your question, Somaru, for example, 120 degrees can be written as 180 minus 60. It can also be written as 90 plus 30. So as you must have studied in trigonometry by now, there are some alternative formulae also that we can use for second quadrant. Okay. But I'm not going to use this over here because the thing is I want to avoid using too many formulae, which might confuse unnecessarily. Okay. That is the only purpose why I am using 180 as a reference and not 90 for the second quadrant. So people just to complete this question now. Okay. I hope all of you got it. I got some messages also here. So for C, Ritika, the angle will not be 45, no, because you can see the components are negative. So it is not lying in the first quadrant. If I say theta is 45, I mean that the vector is lying in the first quadrant, no? So I cannot do that over here for the vector C. For the vector C, you can see that the components are both negative. X component is also negative, Y component is also negative. So X is also minus 2, Y is also minus 2. So immediately you understand that is theta is in which quadrant? It is in quadrant 3. Okay. So to figure out how much exactly theta is in quadrant 3, you have to now use trigonometry. So let me do this question the other way. I'll draw the vector later. Okay. First, let me express it by using trigonometry. So I can see magnitude of C is square root of Cx square plus Cy square. So it is becoming 2 root 2. Okay. And tan theta for C is Cy by Cx. So that is positive 1. But theta is not in first quadrant. Okay. Please understand here that theta is in quadrant 3. You have to apply quadrant 3 formula. So recall, in quadrant 3, tan theta is positive of tan theta minus 180. Okay. So here, tan theta, which is tan of theta minus 180, is plus 1. Okay. So theta minus 180 is equal to 45. So theta is how much? It is 225 degrees. Like this. So if you want to do it, strictly by formula method, this is what we have to stick to. So you have to be very, very correct in your application of trigonometry. That okay, tan theta is 1, but theta is not in the first quadrant. Theta is in third quadrant. So I have to rewrite the formula for third quadrant, which is this one. Okay. So now let us come back to the drawing method. So in the drawing method, it's actually easier. You can see that for the vector C, the x component is minus 2. The y component is also minus 2. So the vector itself is like this. So this is the vector C. And now you will understand that in this, the angle that we are looking for, the angle with respect to the positive x-axis, is this whole angle. This angle. This is the angle theta. Now you can figure out that this is that, isosceles right angle triangle over here. So this angle, this smaller angle here is 45. So it's very easy to understand from the diagram that the total angle theta is actually 180 plus 45. Because these two sides are equal. So you can see in this triangle. So it's very easy to just geometrically understand that theta is actually 180 plus 45. So that's the advantage of drawing the diagram. It makes it very easy to directly understand without getting into so much technicality of trigonometry. It makes it very easy to directly understand. And also you can avoid mistakes. If you just visualize the diagram once before working out the angle and all that, you can avoid mistakes of quadrant. So 45 is correct in that sense, but 45 is the angle it was making with the negative x-axis. So the proper answer for theta, that what is the angle it's making with the positive x-axis here, will in fact become 180 plus 45. Okay. Now like that, let's work out vector D also finally. So vector D is, I think, the one which is in the fourth quadrant. So 12 y cap minus 16 j cap. So you can see here that the x component is positive and the y component is negative. So that means theta is in is in quadrant 4, and magnitude of the vector D is square root of 12 square plus 16 square. So that is 20. So tan theta is minus of 16 by 12 or 4 by 3. Okay. Now you use the quadrant 4 formula. Okay. Meanwhile, if you draw the vector, you will see that it looks like this. Its x component is positive 12. Its y component is minus 16. So this is our vector D. If you also know now has a magnitude of hypotenuse of 12 and 16, which is 20. Now, instead of doing all this trigonometry and what is very lengthy, you can just understand in the diagram here that if we just concentrate on this right angle triangle here, it is a 2, 3, 3, 4, 5 type of triangle, and you will be able to figure out that if you express this angle, for example, as alpha, that alpha is 53 degrees. So what is the proper theta? Okay, the angle theta that we are looking for, that is the angle it is making with the positive x-axis. So that is this angle. So theta is 360 minus alpha, or 307 degrees. Okay. Or we can also express it therefore as minus 53 degrees. Because I told you in fourth quadrant it is easier to express it as, because the angle is clockwise from this side. Okay. So 307 with a positive sign is the same thing as 53 with a minus sign. So it becomes like this. Okay. How we have calculated alpha is that right angle triangle. See, that right angle triangle was like this. That diagram, this angle was alpha, this side was 12, this side was 16, because this is 16. Just as a magnitude, it was 16. Okay. You can see tan alpha is perpendicular upon base, or 4 by 3. So that means alpha is 53 degrees. Okay. Or you can use sine cos also. Similarly, sine alpha in the same diagram is base upon hypotenuse. Sorry, is perpendicular upon hypotenuse. Okay, so that is 4 by 5. So again, that means this. And that is the same thing if I would get if I went by the trigonometry kind of approach. Okay, so theta is in quadrant 4. So I would substitute tan theta as minus of tan 360 minus theta, and that is minus 4 by 3. So this would tell me that 360 minus theta is 53 degrees, or same thing, that theta is . So you can see drawing the diagram to figure out the angle is a more efficient way rather than going with the strict formula of trigonometry, because the strict formula of trigonometry can always result in some kind of mistake with quadrant or sign or something like this. Whereas the moment you draw the vector according to the components, you're very sure about the quadrant. So there will be no problem with the algebraic signs of the components. Okay, people, so hope this is clear. So, with this now we are pretty confident with this process, which is called component representation of vectors. We have seen that there is an interrelationship between the geometrical representation and component representation. Now, next thing we will do is component algebra. That is how we use the component method to do algebraic relations. Okay, so just like for geometrical representation, we had started with the first operation. First algebraic operation was the multiplication of a vector with a scalar. Same over here. Multiplication of a vector with a scalar. So for example, if I say vector B is equal to n times vector E, where n is a scalar, it can be positive or negative. An example of the actual application of this is the equation F is equal to ma. Acceleration is a vector, force is a vector, but mass is a scalar quantity. And here mass is a quantity which is always, it doesn't have algebraic sign positive or negative. But so here for example, so this is an example of that. So here what happens is, if vector E is equal to Ax I cap plus Ay j cap, then when we multiply on the left hand side with a scalar quantity n, on the right hand side it becomes that n multiplied by this. So we just apply the distributive property of multiplication. So जब हमने a को n से multiply किया, on the right hand side n is getting multiplied with this whole bracket, which is a scalar quantity x into I cap plus a scalar quantity Ay into j cap. So you just apply the distributive property. So it becomes n times Ax, the whole thing into I cap, plus n times Ay, the whole thing into j cap. So n times a vector A is the same thing as a new vector with the components becoming n times. Very simple. So for example, if I have that question only, that vector A is, let's say, root 3 I cap plus j cap, okay, and vector B is, let us say, 5 times vector A, then find vector B in I cap j cap notation, okay, and secondly the magnitude of vector B. So you can see that given that B was 5 times vector E, next what we'll do is we'll just substitute in this equation that B is equal to 5 times A, we'll substitute the value of A in component form. Okay. So given this, it means that the vector B is 5 times multiplied by whatever vector A was given to me, which is root 3 I cap plus j cap. So vector B, as you can see in component notation, is becoming 5 root 3 I cap plus 5 j cap. So that's the first part's answer. And the magnitude of vector B is just square root of its x component square plus y component square. So that is 5 root 3 whole square plus 5 square, from which you can take 5 common and you have 3 plus 1. So as you can see, that is 10. Okay. So vector B's magnitude is becoming 10. So that becomes the second part's answer. Okay, so this is extremely simple. There's nothing complicated about this. Okay. It's just basically you're using the property of multiplication, which we call distributive property. So I'll just take you to the theorem first, and then we'll see the example again. So our first type of operation using component notation is multiplication of a vector with a scalar quantity. So if we say we are multiplying the vector A with a scalar quantity n, then the vector vector's components becomes n times ax and n times ay. So n times vector A is nothing but n times x component plus n times y component. Yes, you can see the magnitude of A in the above, in the example below is 2, and the magnitude of B came out to be 10, which also satisfies yes. That if I am saying vector B is 5 times vector A, then obviously magnitude of vector B must be 5 times magnitude of vector A. So this vector equation that I have written, that B is equal to 5A. Now if I take mod on both sides, so mod of B will have to become mod of 5A, that is 5 multiplied by mod A, which is again you can see working out, because mod of B is 10 and mod of A if you separately work out is 2. So in general, it will also satisfy this property, that if vector B is n times vector E, then mod of B should become mod of n times mod of E. Because n could also be a negative number now. So for example here, if B is equal to 5A, then mod B should be equal to 5 times mod B. And you can see that mod B is coming out to be 10, whereas mod A, if it worked out earlier, was coming out to be 2. So you can see that condition is satisfied. Okay, so this is very simple. It's self-explanatory. Nothing. So you'll see component algebra is actually very simple. It's almost like applying the principles of normal algebra. Like here we have the very normal principle from algebra of distributive property of multiplication. That x times a plus b just becomes x times a plus x times b. So it's like you're using that only. But additionally, there are the unit vectors. Okay, so that's how it's coming. Now next operation we will see using components is addition of vectors. Previously we've learned addition of two vectors by triangle law. Now we'll look at the general property of addition of vectors, where we can add more than two vectors also, but by using component methods. Okay. We want to find out A, given that the vector A is axi cap plus ayj cap, and the vector B is bxi cap plus byj cap. So given this, now we can see A plus B. Now we're solving this. Okay. Now just substitute A in the component form, because it was given like this. So it's axi cap plus ayj cap plus B, which you substitute in the component form again. So bxi cap plus byj cap. And now again you use the normal principles of algebra, that you can take common. So if you just open these brackets, you have axi plus bxi, you have ayj plus byj. You just take I cap common and you have ax plus bx. The whole thing into I cap plus ay plus by. The whole thing into j cap. So this becomes a formula for the vector sum of A and B. This becomes a formula that the sum of A and B has an x component, which is the sum of the individual x components, ax and bx. It has a y component, which is the individual sum of the y components, ay and by. So this becomes a generic formula for vector addition of two vectors using this. Now from this we'll also see that we can add any number of vectors now, because we have to just extend this formula. Whereas in our triangle law earlier, we were restricted to adding two vectors. So this is a very useful way of doing the sum of vectors. Okay. So it's pretty obvious. Okay. Now, for example, if I have a direct question like this, that two vectors are given to me. Suppose vector E is given to me as I cap plus j cap, and vector B is given to me as, let us say, 2 I cap plus 3 j cap. Now ask find vector E plus B in component notation and magnitude of A plus B. Find this out. So it's very simple. All you have to do is substitute. So here vector E plus B. Now eventually you won't have to write so many steps as I'm writing, but initially I'm just showing you each one. So substitute A, which was given in component form, which was given as I cap plus j cap, and then substitute B, which was given in component form as 2 I cap plus 3 j cap, and then you can see that the sum of the x components is 1 plus 2, so that's 3 I cap plus the sum of the y components, which is 1 plus 3, so this is becoming 3 I cap plus 4 j cap. So once you get used to this, आपको इतने सारे steps नहीं करने की जरूरत है. You can directly look at the two vectors which are given to you above, and you can directly figure out that once you get used to this, when you look at these two vectors, you can just figure out that okay, the vector E plus B now will have an x component which is the sum of this x component, which is 1 and 2, so it is 3 I cap, and the y component will be the sum of this component, which is 1, and this component, which is 3, so that is 4 j cap. So eventually you can do it just directly like this, okay, but initially I'm just showing you all the steps involved. So the steps are this, okay. So we have found out the vector E plus B in component notation. Now next we have to also find out its magnitude. So magnitude of A plus B is nothing but magnitude of this vector 3 I cap plus 4 j cap, which you know is 5. Because the magnitude of any vector in I cap j cap form is nothing but the x component square plus, so that is 5. So that becomes the answer. It's as simple as that. As you can see, there's nothing at all which is anything complicated about this. This is just like the simple application of normal algebra, but along with that, the concept of magnitude of a vector in terms of components. That's all that is added. So make a quick note of this. Okay, so hope this is clear. Now, just to make one point very clear to you people, note that when we are adding AX and AY like that, the components, they must be with proper algebraic sign. So for example, if I have a vector like this now, which is, let's say, 2i cap minus j cap, and I have a vector b, which is, let's say, minus I cap plus, let's say, 4j cap, and I ask you to find the vector E plus B. Okay. So in terms of formula, remember, this is Ax plus Bx I cap plus Ay plus By j cap. This is the formula for it. Now see over here that the y component of A is actually a negative quantity. So when I substitute over here for Ay, it must come with a minus sign. You can see the x component of A, of B rather, is a negative quantity. So when I substitute here Bx, it must come with a negative sign. So you must remember that when you substitute here, it is with algebraic sign. Yes. So Ax will be 2 and Bx will be minus 1. So this is what we have to multiply with I cap. And similarly over here, Ay will be minus 1 and Bx will be 4. So in this case, this actually becomes I cap plus 3j cap. So in a hurry, while doing questions, don't forget the minus sign over here, because then you will get the wrong answer. Okay. So A plus B in component form will become like this, and therefore magnitude of A plus B just become root of 1 plus 9. So, okay. So that is something you have to be mindful of while doing questions. Okay. Components Ax, Ay, Bx, By, etc. must be substituted with their algebraic sign. Okay. So that's what this example is just showing. Okay, so hope this is clear. Now likewise, if I am doing addition of more than two vectors, like suppose I have A plus B plus C plus D, another two vectors are there. So just by doing the repeated, application of this will just become Ax plus Bx plus Cx plus Dx, as simple as that. You don't have to keep adding A plus B, then add that to C. You don't have to do so many steps. You can just add them all in the same. So Ay plus By plus Cy plus Dy into J. Okay. So this is what happens for multiple vectors. Okay. So whatever number of vectors we are adding, just add all their x components and multiply that with I cap. Then add all their y components, multiply with j cap, and that's it. You got the sum. Similarly, for difference of two vectors. So E minus B, that will just become Ex I cap plus Ey j cap minus of Bx I cap plus By j cap. So now just apply the normal principles of subtraction. That when you open this bracket, the minus sign gets distributed here, and then you take I cap common. So you have Ex minus Bx I cap plus Ey minus By j. So this becomes like a general formula now for the vector E minus. So for the sum of two vectors, we have the sum of x components and sum of y components. For the difference of two vectors, we have difference of x components into I cap plus difference of y components into j cap. So as you can see, again, all these operations become very, very easy once we express the vectors in component form. In fact, that is why the primary method that we use in physics for solving things related to vectors is the component algebra form. Geometrical form we use only for specific types of questions where the geometry is going to be useful. Otherwise, we are going to use the, we won't, typically be using the triangle law and all that often. More often, we'll be using the component method of doing addition, subtraction, and all such operations. You can say that the preferred method for vector algebra is the component method. Okay. Now let us see how we can use the component method to solve a problem even where the information given is not in components. That is the indirect way of solving. So suppose given that magnitude of vector E is, let us say, 40 units. Magnitude of vector B is, let us say, 30 root 2 units. And theta, the angle between them, is 135 degrees. This is the angle between vectors A and B. Now, to find out magnitude of A plus B. Now, this looks like a typical candidate of what? The triangle law, because everything is given to you in mod form and angle form. You can directly substitute in the triangle, but we can also do this by component algebra. Okay? So, find this out by using triangle law. Of vector addition. But let's also find it out by using component algebra. And obviously by both the methods, the answer should come out to be the same. So let's see how that works out. Okay. So just take down the parameters of the question. I will work it out for you. In fact, why don't you do this? Try this out yourself. Use the triangle law. So I'll just remind you what the triangle law is. Okay. According to the triangle law statement, mod of the resultant of two vectors is square root of E square plus B square plus 2ab cos theta. Okay, just a minute. Make a correction here. Let's make this question a little bit easier to solve. So instead of 40, just make a small correction, guys. Let us make this 70. Just be easier to solve. You can solve for 40 also, there's no problem, but this will just be easier to solve. So try the first part, A part yourself by substituting everything in this formula. mod A is given to you, mod B is given to you, and theta is given to you. Now just substitute correctly and tell me how much will be the answer. Yeah, hope you're understanding this, all of you. How much is the answer coming out to be? Very good, Rahul, that is correct. Rahul, the answer you sent me is correct. Good. Tanish, why are you getting? No, that's not correct actually. Yes, Durgesh, that's correct. Atharva, very good, that's correct. Varun, just check your calculation once. Hope you use the value 70 for mod A. So the whole question is how much is cos of 135? 135 is second quadrant. So it will be minus cos 45. Okay, so substituting here further, you will get this as square root of 70 square plus 30 root 2 ka whole square. Yes, Yojit, that's correct. Very good. Plus 2 times 70 into 30 root 2. Can you substitute? Priyank, check your calculation again. Into cos 135. This is where you have to be very careful. Cos 135 का algebraic sign सही होना चाहिए, otherwise you will get the wrong answer. So before we continue here, we'll understand that cos 135 degrees is minus of cos 180 minus 135. So minus cos 45. So minus 1 by root 2. Okay. So therefore you can see that mod of A plus B is becoming square root of 70 square plus 30 root 2 square plus this whole thing 2 into AB. So that is 70 into 30 root 2 into cos theta, which is now a negative number. It is minus of 1 by root 2. Okay. So hope this step is clear to all of you. This one. Cos theta is to be substituted as this. So this is becoming square root of 4900 plus 900 into 2, so that is 1800. ये minus हो जाएगा because this minus sign comes outside. Root 2 cancels out, and how much we get? 70 into 30, so that's 210 into 2, so 4200. So when you work this out, this comes out to be square root of 700 plus 1800, so that is 2500. So that you can see will become 50 units. So that is my magnitude of A plus B. Yeah, 40 would have given us something different. Okay, but that's why I modified it to 70 so that we get a whole number. Anyway, more important is the method of solving, which is this. So basically here we are substituting magnitude of A as 70, magnitude of B as 30 root 2 and the angle between them as 135. So that's what we substitute. Yes, yes, you have to remember the values of trigonometry in 4 quadrants. Otherwise, these things will go wrong for you. Okay. All right, now let us also see how to do this by the component method. So B part, using component algebra. So for that, first of all, I will have to convert the given information into component based information. Now see, since nothing was actually told about the direction of the vector E, whether it is along a particular x-axis or not, only thing given to me was that the magnitude of the vector E was 70, the magnitude of the vector B was 30 root 2, and the angle between them was 135. So this is the angle between A and B. So now I can assume A is along any direction, but then B should be at 135. Or in other words, I can draw my x-axis to be along A. So in this diagram, let me assume that the vector A, or I have drawn my axis such that the x-axis is actually along vector E. So in that case, the vector E would have to look like this. So assuming that we have drawn a coordinate frame such that the x-axis is made along the direction of vector. That's an assumption I'm making, and I'm free to draw my x-axis as I want. So there's no instruction in the question about it. Okay. Then accordingly, where will my vector B lie? My vector B will lie somewhere like this. In comparison, the vector B would be such that with respect to vector A, it's making an angle of 135, and its magnitude is 30. So once I've got this diagram worked out with the assumption that the x-axis is along A, now I can express vector A and B in component form. So next step, what we'll do here is express the vectors A and B in component notation. And then find A plus B, again in component notation. And finally, find magnitude of A plus B. Okay. So make this diagram and now work out the second and third step yourself. The first step was to place the vectors A and B according to the instruction given in the question, that their angle is 135. There's no instruction about the x-axis, so I'm taking x-axis according to my convenience. So my convenience is this, that I've taken my x-axis along E. So yes, that is correct. Now express the vectors A and B in component form. That is your next step. And once you've done that, just use the component algebra for the sum to find A plus B in component form. Shikhar, I'm getting your message now, but earlier I have not got any message from you, I think. Yeah, Shikhar, I'm getting your messages now. So yeah, we'll do examples of difference also, Hitesh, to answer your question. Hitanshu, sorry. Okay, so first of all, now in component form, vector E will become how much? It will be 70 I cap. But about vector B, you have to be a little careful. The vector B is having negative x component. It's minus 30 I cap plus positive y component j cap. Okay. So again, just see how the vector B was drawn. It was like this. It was in the second quadrant because it's making 135 degrees with the x-axis. So my vector B was drawn like this. Its magnitude was 30 root 2. This angle was 135. Okay. So that also means here that for the vector B, this angle is 45. So when you drop this perpendicular, this is that isosceles right angle triangle. So this will be 30 root 2 into 1 by root 2. So it will be 30, but it's on the negative side. So it's minus 30. And similarly, this is on the positive side. So it will be plus 30. So that is why the vector B is having these kind of components. That is why the vector B is having negative 30x component and positive 30y component. Okay. So now you can see that E plus B is just becoming 70 plus of minus 30 I cap plus 0 plus 30 j cap. So that is 40 I cap plus 30 j cap. So this is now the resultant but expressed in component form. So finally, to find the magnitude of the resultant, you have to just find mod of 30 j cap plus 40 I cap, which you know is 50. It's very simple. So finally, therefore, it is just the magnitude of this vector. It is root of x square plus y square, which you know is 50. That's it, that becomes your answer. So this is the alternate way of doing the question, and we'll see that most often this is the more convenient way of solving the problem. You're going to see that component algebra is going to be typically the more convenient way of solving the question. Other than certain special questions where we can think of geometrical method as a shortcut formula or as a shortcut method because it might be having some kind of symmetry, etc. The given problem. All right, so hope this is clear. Now let's do one more final question using component algebra, where we have a bit more of operations also, not just addition. So next, let's pick up an example like this, where suppose now we have these three vectors shown to us. This is the vector E, suppose. It's at an angle of 53 degrees like this, and its magnitude is, let us say, 50. Then we have another vector V, let's say, which is something like this. And V is the same one as we had drawn in the last one. It's 30 root 2, where this angle is 45 degrees. And we have a third vector C, which is like this, let's say. Which is having a magnitude of whatever, let's say 30. Okay. So we want to now find E plus B minus C. I want to find this and the magnitude of the same thing. What is the magnitude of the vector, which we are getting by the operation of adding the vectors A and B and then subtracting C from it. Okay. So with practice, this kind of question will become fairly standard for you. So the method of solving is the same. First, from the diagram, convert the given equations into component form. Convert the given arrows, given geometrical arrows into component form. Once you've done that, just substitute it in the operation. You start by expressing these vectors A, B, and C in component form here. Then you can proceed from there. Yes, very good, Shomaru. That's correct. Vector A's component form is correct for you. Similarly, vector B and C, you work it out. Now, vector B you can see is the same as what we had done in last question. So you can just repeat that. Okay, so very good. So Murup, your answer is correct. Okay. Only thing is the final step is minus C. So Varun, your answer is correct. The final answer you should get for this part, E plus B, sorry, minus C. This thing you should be getting as, in fact, 100 J cap, 100 J cap you should be getting. Okay. And therefore the magnitude of the same is just 100. Now let's see how that's happening. Yes. So the vector E, when you process it in component form, it should come out to be 30 I cap plus 40 J cap. Just check, you should be getting this one because magnitude of A is 50 and the angle it is making with the x-axis is 53 degrees. So using that AXAY formula. Similarly, the vector B, we've already seen, but so I'm just using that same vector which we did in the previous one. So that is minus 30 I cap plus 30 J cap, because the magnitude of the vector B was 30 root 2 and the angle with the x-axis is in fact 135 degrees. And the vector C, from the diagram you can see, the vector C is pointing down. So it is just minus 30 J cap. Just like this. Okay. So now we'll pick up these values of A, B and C in component notation and just substitute in what we're doing. So in trying to find out this quantity, A plus of B minus of the vector C as a vector quantity, we'll just substitute A according to what we had. So A was 30 I cap plus 40 J cap. Then to that we'll add B, which was minus 30 I cap plus 30 J cap. And then to that we'll subtract C, and C itself was minus 30 J cap. So this becomes the whole operation. So now if you take your I cap common, you can see you have 30 minus 30 plus 0 I cap. And for J cap, you have 40 plus of 30 minus of minus. So that becomes plus. That's it. That becomes your answer. It becomes 100 J cap. So this is how these kind of hybrid calculations, which are neither addition nor subtraction, but two things are added, one thing is subtracted, or any kind of combination of this can be done by using the component method. So whether the vectors are already given to us in component form or they are actually given in a diagram and we have to convert to component form. But typically for addition, subtraction type of operations, your component method should be the first option you think about. For some reason, if you think that component method is too lengthy, and in that particular question, if you visualize the vector triangle or something and it's directly very easy to solve because of symmetry, then you go with the geometrical method. Otherwise, you try to rely on the component algebra method. Okay. So people hope all this is clear, and with this we come to a conclusion for today's session. Okay. So I will be sending you a worksheet today itself, which will have questions which are both from the previous lectures geometrical methods as well as this particular lecture's component algebra methods. So try to complete that worksheet in the next 2 or 3 days, and we will discuss it in the next lecture, but you can start sending me your doubts also. And I forgot who, but somebody had asked me about question 14 from worksheet 2 at the beginning of the lecture. So if you just send it to me as a doubt on WhatsApp, I will send you a solution of it. I'll help you out with it. But you can also now attempt that question using this component algebra method that we've discussed. So you'll also get a very interesting solution of that question 14 if you use component method instead of triangle law method. However, I will send you an explanation of it using that also. But just be sure to send me a single WhatsApp message on that, because I have too many messages piled up one on top of the other, so I'll otherwise not be able to see. Okay. So that's it for today, people. Thank you, and until the next lecture or your mentoring session, stay safe and study hard, but also keep some time for your family and some kind of activities that make you happy and keep you fresh for your studies. That's it for today. That's all.